Here I'd like to introduce Adam Thimling and Jordan Porter. We're working on a production work cell improvement project with Jasper Engines. Gentlemen, take it away.
Welcome. Thank you for joining our senior project presentation. My name is Jordan Porter. This is Adam Thimling. As Nelson just said, we chose Jasper Engines and Transmissions for our senior project design. Jasper Engines and Transmissions is located here in Jasper, Indiana. It's about an hour northeast of Evansville. They are the nation's leading remanufacturer of a diverse line of automobile drivetrain components. When you need a drivetrain replacement, they are the go-to company for high-quality engines and transmissions.
The objective of the project was to improve the process layout and process flow for a work cell. The work cell assigned by Jasper Engines to us consists of the remanufacturing process of the valve body and pump from the TR-180 transmissions, as you can see on the pictures posted below. The TR-180 transmissions are most commonly found in mail delivery trucks or milk carriers.
As you just saw, this is the valve body out of the TR-180 transmission. In the top left corner, you see the valve body, and it is disassembled. The valves that you can see below are what go in there, and the springs as well. The valve body located on the transmission, it's on the bottom part of the transmission. If you take the transmission pan off, you will see the valve body. It's the control center of the automatic transmission and can be thought of as the brain of the transmission. As you can see in the picture, it contains a maze of channels and passages which direct the transmission fluid to these numerous different valves.
And for those of you who aren't familiar with how a transmission pump works, transmission pumps draw hydraulic fluid from the bottom of the transmission, and that fluid is then supplied to various components of the transmission. This keeps the transmission well lubricated and running fluently, smoothly, and effectively. And the work cell we did as a process observation for currently runs at 4 associates, 2 of them being on the valve bodies that are being rebuilt and 2 on the pumps. The current quota for Jasper Engines operations is to remanufacture 22 transmissions per day. That means 22 valve bodies and 22 pumps in one day. The current cycle time for operations is 40 minutes. That means that each valve body and each pump worker have to build one of those in 40 minutes. So the layout that you see on the slide, it's set up so that all the workstations are set side by side, 2 of the valve bodies and 2 of the pumps for the workers. And you have all the work being done about all the work done being on those tables, with the exception of some of the other equipment in the area, like over here. You have the high pressure washer to get rid of residue, you have your drying stand, you have your sanding table over here, pump cart, and there's also equipment and other stations set up outside of the cell that the associates have to walk to complete some of their steps in their process. As you can see here, this is 2 of the valve body stations located right next to each other. You've got the 2 pump stations to the left of the valve bodies next to them, and to the right of all 4 of those, you've got one of the solvent stations right here, the yellow one. You've got your drying stand, and you've got your high pressure washer. And the remanufacturing process for the valve bodies and the pumps follow a specific sequence. And the first of those sequences is to disassemble the pump or the valve body, inspect for damage and any scrap parts. Those get thrown out, and they get replaced with good pieces from other remanufactured valve bodies or pumps from previous processes. The second is to wash, make like new, or to refurbish the valve body or pump, and to bring back the quality of the product like it was brand new. And the third sequence is to reassemble, to place all the components back into the pump or valve body so it can be sent off for the next assembly stage.
So in order to find out the problem areas in the valve body remanufacturing process, we had to perform a time study, and that's what you see on this chart here. We broke down the process into 18 different steps. This actually is on 2 slides. There's 1 through 9 there, 10 through 18 on this slide. I've grouped them into 3 different groups. The group 1 consists of the disassembly of the valve body. Group 2 shows the washing and the refurbishing of the valve body. And then here in 3, it shows, this is like the assembly process, putting the valve body all back together. For the running time, we just had a stopwatch. When they started the cycle, started the time. After that step was complete, we wrote down the time. So the running time, you just write down the time off the stopwatch. The time per step, that was calculated by taking, by subtracting each successive step from each other. For example, take step 2, subtract it from step 1. So you've got, in cycle 1, you've got 32 seconds, you subtract 17. That's 15 seconds. So your time per step for step 2 on average is 15 seconds for cycle 1. As you can see in the bottom right corner, on average, it took about 24 minutes per cycle time on the rebuilding of the valve body.
Similar to the valve body time study, problem areas needed to be determined and to be brought up for the pump rebuild process. The pump cycle was broken down into a lot fewer steps than the valve bodies was. 1 and 2 on the diagram being the disassembly process, which is the removing of the valves and checking the bushing and inspecting for bad parts on the pump. 3 and 4 being the refurbishing steps, which is to polish the pump and sand the face of the pump, and then to wash the pump and dry it and get rid of all the extra residue. And then steps 5 and 6 belong to group 3, which is the reassembly process, which is the fitting of the gears that go back into the pump, and then putting all the valves back in and finishing the reassembly. 3 cycles were timed in order to get the average running time, same as the valve body. And for the pump time study, we got an average of 21 minutes.
When planning for the future proposal, we had a few ideas in mind. First, we wanted to decide if there was the necessary or the correct number of associates in this area. As Adam stated earlier, there's 4 associates working in this work cell. There's 2 working on the pump, 2 working on the valve body. We needed to see if this was the correct amount or not. Secondly, we wanted to consider some ergonomic issues. Basically, ergonomics, if you're not aware, is making the job fit the person. We don't want to. We want to minimize operator fatigue and discomfort. We don't want to put stress and strain on our muscles, because these things that they're going to be doing, 22 times a day, and over time that can put wear and cause problems with the body. Thirdly, we wanted to use cellular layout that accommodates Jasper Engine's methodology. Fourth, we wanted to create some flow and organization. As you'll see here in the future, you'll see that there's not a whole lot of flow currently in the process. And lastly, we wanted to eliminate the steps that did not add value, so the non-value added steps.
And like number 5 said, to eliminate non-value added steps, we came up with a process flow diagram to explain how value added and non-value added works. As you can see on the upper levels of the diagram, you have steps that either add parts to the product or add work to the product or work that has been done to the product. Those are all steps that will add value that what the customer is paying for. Anything on the lower level, which you'll see is all walking for this process, there's stuff like wasting time, waiting to use a machine, waiting to use waiting to do something in particular. All of that is considered non-value added. It's like paying for somebody to stand around. Nobody wants to do that. So part of planning the proposal and layout for this cell, we want to try to get rid of all of the lower levels, or as many of the lower level steps as possible in the diagram, so that all we have are upper level value added procedures in the process.
All right, what you see here is the current valve body process flow layout. This is an aerial view, bird's eye view looking over the work cell. As we stated earlier, the majority of the work is actually done in this area. As you can see, all these blue lines represent the path that the associate has to walk in order to complete one cycle, to rebuild. In other words, this is what has to happen in order to rebuild one valve body. Like I said, they're leaving their work area a lot to go to.
Oh, sorry.
They're leaving the work area a lot to go to use different machines, go to the washer, go obtain a valve body and stuff like that. The average cycle time right now, like I said earlier, is 24 minutes, and they're actually walking over 4.5 minutes on each cycle. Now this is our proposed layout. Seen in red are what the equipment that we have added. We wanted to come up with a U-shaped design. As you can see, the material now flows in a U-shape, and we've reduced walking time dramatically. I'm going to flip back and forth between the two, but basically just kind of run you through the steps of the rebuild process. First, beforehand, when they would go to obtain a pump, they would have to go all the way out of the workstation to come up here to disassembly, follow one, and then they have to bring it back. Now what we have done is we have implemented a rack which they can just walk over to and pick up the valve body that's going to be remanufactured. They then bring that over to the disassembly workstation where they take it apart, take the valve, take the springs out of it. After that, it's brought over to the valve body washer. Before, what was happening? Before, valve body washers right here. Before what happened, they would bring it back, then they would disassemble, and then they would have to walk all the way back up and around to the washer for that washer to wash it. So implementing a washer inside the work cell is going to save a lot of time, a lot of walking time. Next, after that, it goes over here to the assembly table. This is where they file down the valve body, make sure it's nice and flat, nice and smooth. They then must walk over to the tabletop high pressure washer. After they wash it, when they go over here to the washer, it's done by hand, manually. They then bring it to the drying stand where they dry it off with compressed air. It's then brought back over to the valve body assembly workstation, and then that's when they polish the valves that are inside the valve body. As you can see before, or currently what's happening is the polisher is way up here at the top right corner. So they're walking, it's about 20 seconds to get up there and back. So they're losing 40 seconds every cycle just walking to polish the valves. Sometimes the valves don't want to go in very well. They have to polish them more, so if they have to keep walking back and forth, and that's adding a lot of time to the cycle. So what we've proposed is to place the polisher literally right beside the assembly workstation. And then once it has been assembled, it's going to go right onto the rack beside it. So we've added these input and output racks. We've added the valve body washer and the valve polisher. Doing all this has allowed us to actually cut out one of the employees. As we said earlier, there was 2 employees working on the valve body, 2 on the pumps. So we're going to actually be able to cut a whole worker out. They can be relocated in the plant somewhere. So we've reduced the associates by 50%.
Okay. Similar to the valve body, the current pump process flow, as you see the blue arrows, are the walking paths for the pump associates to complete their process. As you'll see where he's standing over here by his pump workstation, he makes his way up to the pump cart to grab the pump, bring it back to his station to complete the disassembly process, where then, step 3, he makes his way up out of the cell, which is included a lot of the walking that's involved. He'll have to polish the pump, make his way back to the sanding table, sand it, make his way over to the high pressure washer and wash that off, bring it over to the dryer and dry it, and then make his way back to the station to do the reassembly process, where then when he needs to take that pump to the next area, he has to walk out of his cell to the adjacent cell and figure out where to place that pump and then return to his area to continue the process. As you see, it's asynchronous. There's no direct flow to how this works. That can create a lot of errors. And one of the problems that we ran into watching this area, they'll go build a pump and then they'll send it off, and when they come back, the other person that's building pumps, they'll set them on a cart halfway between when they do their process, and if they don't have any specific work instructions they follow, and they'll go look for the pump, and sometimes they don't know how far that pump has been disassembled or how much refurbishing has been done on it, so there's a lot of confusion in there. And so for the proposed pump process flow, similar to the layout that the valve body has, we added right here and on the input and on the output the pump racks, so that the associate can just grab the pump that's needed to be worked on from the area previous to that, disassemble, move his way over to where we added a pump polisher so he can polish the pumps, not have to worry about waiting for the machine to be available or to walk out of the cell. It's all in this relative cell for him to use. Then he makes his way down to the sanding table, back to the high pressure washer to wash, the drying stand, over to the pump assembly where the reassembly occurs, and then back and forth between the sanding table to fit the gears as necessary, makes his way over to the pump rack to drop off the pump after the reassembly is completed. And as Jordan mentioned, with that process we have the uniform U-shaped cellular layout that we want, that Jasper Engines recommends as a guideline for all of their processes. So we made that happen, and Jordan's going to discuss.
And also, you can notice on those, they never have to leave the workstation. That was our entire point. You know, they can stay in this one area and completely rebuild or remanufacture the pumps and the valve bodies all in this work cell without having to leave. So currently, the valve body remanufacturing process takes about 24 minutes. By reducing 4 minutes of walking time, we can now drop this cycle time down to 20 minutes. With the pumps, it's at 21 minutes on average for cycle time, reducing walking because the pump's not as involved. By reducing the walking, we can get this down to approximately 20 minutes. So currently, each worker has 40 minutes to remanufacture these pumps and valve bodies. If you allow somebody 40 minutes to do a job, it's going to take them 40 minutes. So these 20-minute tasks ended up drawing out to be a 40-minute task. With the extra time that they have, you might wonder what they're doing. Oh, well, they got all this extra time, what are they doing? Well, sometimes, like the group's supervisor, the leader, realizes that they have an extra time. Sometimes they will ask them to take a transmission that's been complete and walk it across the plant to shipping. They just give them extra tasks because they realize they have too much time on their hands. Some of them will take extra breaks. They'll chit-chat with their friend or with their coworkers, and also they'll just kind of work slow, work at their own pace, do whatever they want. Quite honestly, some other factors: the uniform flow that you saw in these proposed layouts will reduce the amount of errors. They're going to continue. They're going to do the same thing over and over all day. The more you do something, the less chance of error you have, and this should also reduce. Currently, sometimes they have to wait for a machine to open up or for a polisher to open up. This should reduce that happening.
With the equipment that we added so that the U-shaped cellular layout was possible without them having to walk out, try to use other machines that other associates used, we came up with estimates for the equipment that needed to be added. And for the valve body racks, that cost, and same as the pump racks, the costs are based off of just labor and the materials or the cost of the material going into these racks. So valve body racks came out to be about $370, pump racks at $330. And for the valve body washer, that was based off of a quote that Jasper Engines had given us and some research we'd done online about these type of washers. It came out to be about $5,000. And the same thing goes for the pump and valve body polishers. Those two combined with a purchase of $1,250. And in addition to the equipment costs, you have to worry about the work costs that go into the implementation of this cell also. Like you got down there the contractor work, which is what Jordan and I did. We put in about 24 hours total at $100 an hour for both of us. We've got the electrical work that goes into it, so when you move all the machines around, you install the new machines that need to be implemented. The electrician needs to be able to hook those up and get things running. And you also got moving and installing of the pressure washer, the installing of the valve body washer, installing of the pump polisher, the installing of the valve body polisher, and moving of equipment and tables so that the U-shaped layout is possible with our proposal. And the overall project cost after adding all that up came out to be about $14,400.
So, assuming the average associate that's working on these lines, building these pumps and valve bodies, makes about $16 an hour, this turns out to be about $36,000 a year is what they are costing the company. So by being able to relocate these two associates, one from the valve body and one from the pump area, this work cell can now save $72,000 a year. But for the first year, we must take into account these implementation costs of what you just covered, installing all the new machines, moving stuff around, buying equipment. You gotta take that into account. So in the first year, they're going to save $57,600. So this year is showing the annual cost savings. Like I just said, after the first year, they will save $57,000 or $57,600. Year two, they're going to save the $72,000 plus the first year savings. Since obviously the second, third, fourth years they don't have the implementation costs. That's just a one-time thing. So you can see after 5 years, if they do this proposed layout, they will save the company about $345,000 just after 5 years. This is a break-even chart. It shows the savings per time. The blue line is currently the cost of the 4 associates working in this area. You can. This is only for one year. So 4 associates at $36,000 a year is costing them nearly $150,000. Now looking at the red line, this is a proposed cost. Obviously you got to calculate in, so at time 0, you're going to have the cost of $14,400 to implement this. And then by reducing the 2 employees, you're going to reduce the salary, or you're going to reduce your total cost from almost $150,000 to only it's going to be $72,000 a year you're paying for labor. So you can see just after 1 year, and actually just after 2.5 months, it's the break-even point. That means that they will get their investment back. So if they implement this, just in 2.5 months, they can start saving the company money. If this chart went on, these lines are linear. So over time, the difference is just going to get greater and greater. So 10 years down the road, they're going to save millions of dollars.
And that concludes our presentation. We'd like to thank Jasper Engine and Transmissions for making this all possible, letting us work on one of their lines and give them our input. Mark Bosmeyer and John Schrader are the 2 guys that oversaw us at the company themselves. The administrative assistant, Donna Moore, department chair, Dr. Zane Mitchell, faculty advisor, Kevin Nelson, and other engineering faculty members and fellow students in engineering who helped us along the way. Questions from you guys?
All right, questions? Any questions over here? Let's see. I'll come up with something here. Have you discussed this at all with the employees? The folks working in the area.
The associates on the line, yeah.
Yeah. What do the associates think about this idea?
With the whole planning of the implementation, we had to get their input because the associates on the line are the most valuable source of data because otherwise we wouldn't know exactly how operations were going, the things that they did. Obviously, we know that they go to other sides of the plant to help out, to drop things off, and that stuff that they gave us is inside data. So we asked them, with this plan, if this was possible. Now, a couple of people said, yeah, that sounds great because it doesn't really make sense how, we have all this extra time to walk around and help out where else it's needed, but instead just keep working in this area. And we also spoke with the team leader of that, the whole pod in general, not just this cell. He was saying that it's a possibility that it might not work as far as, bringing it down to 2 workers, giving him that 20-minute time because he was more concerned about the errors that occur, problems with the pump or problems with the valve body so that they have to go get the team leader, and keep working on that pump or the valve body. And then that's just going to extend the time that they have to keep working. Well, I mean, with the exclusion of all the walking time that we had in there, and then when he just mentioned, you give somebody a 40-minute time limit for a 20-minute job, they're going to make that happen. Well, you just got to crunch that down on them. And since we're trying to implement lean manufacturing, we don't want extra time available for them to go do whatever they need to do. And we talked about that with them, kind of gave them that idea. We didn't want to just, make it seem like we're making it difficult on them. But according to the team leader, he thought it was a pretty good idea as long as we got all of our facts correct. And so far, it looks so good to them.
I was going to add to that. The associates, we spoke with them, and they did realize that there were some problem areas, especially, having to walk so far to go to the polisher. That's one thing I heard them complain a lot about, walking so far to go to the polisher. That's one reason why we have this project, because they realized that this is a problem area, and they wanted to see what we could come up with. The workers really didn't have a whole lot of input and have a whole lot of advice, but I mean, they do realize that they're doing a lot of extra walking. They probably don't realize how much walking they actually are doing. Because like I said, sometimes the pump or sometimes the valves won't actually fit correctly into the valve body when it goes back together. And they have to walk, 20 seconds and back and forth and, keep filing on it, keep polishing it down, try to get the fit. So I know one of my time studies that I did, it was almost like 10 or 12 minutes to assemble it, and the rest of them were only like 5 and 6 minutes. So I mean, it added 5 minutes just trying to walk back and forth and get it right.
And one of the things I tried to communicate with some of the associates is that, you know, you learned how to do this job, you know, in a certain amount of time. They gave you the instructions that you needed. But if you were to do this for future associates coming into this line, you know, would you be able to teach that to them in such a short amount of time that they can start working like without your assistance the next day? And with the implementation of our idea, so that that uniform flow is keep going, don't let anything else distract you, don't worry about all the other things, and don't have to worry about, you know, do I have to go to this area to drop off the pump, or do I have to go to this area to drop off the pump or pick up the pump? With the idea that we have, it's just a synchronous flow. There's no distractions, there's no in-between. So I feel like with this, it would be a lot easier to teach a new employee coming into that area and get it down packed in such a shorter amount of time.
Okay. Any other questions? What's that? No, they don't have to have another question. All right, if there aren't any other questions, let's give them a hand.